Good day and welcome to the Math Salon. I'm Dr. Animendem. We are going to look at equation on complex numbers, actually looking for the fourth root of a complex number. So the equation says solve the equation z to the fourth plus 8 root 3i minus 8 is equal to 0, where z is a complex number. I think before we do this, it's important to think a little, because if I write this as z to the fourth plus 8 root 3 I minus 8 is equal to 0. This means z to the fourth can be written, I take everything to the other side as 8 minus 8 root 3i. So here I can actually look for the fourth root of both sides. But to get the root of a complex equation, one of the key ways is expressing this in polar coordinates or in trigonometric form. And if we do that, then it's much more easier. We can use some ideas that we know. Let's assume, for example, that this complex number r cos theta plus I sine theta is the nth root of another complex number, small r cos alpha plus I sine alpha. Let's assume if this is the nth root of this, it means that this raised to the power n should be equal to this. This means r to the power n cos theta plus I sine theta, or that to the power n should be equal to r cos alpha plus I sine alpha. Yeah, that's true. If the square root of 4 is 2, it means 2 squared is equal to 4, right? If 2 is the square root of 4, it means that 2 squared should be equal to 4. That's just what we are doing here. If that is true, then it means that I can equate this. That means r to the n is equal to small r, and this implies my r, big R, is equal to nth root of r. And what about the theta? We already saw this. If you look at the De Moivre's theorem, it says that the n can go there. So this becomes cos n theta plus I sine n theta. Look back at one of my videos and you will see this. This should be equal to this part, cos alpha plus I sine alpha. If I want to look for the general solution, I can say the real part should be equal to the real part, the imaginary part should be equal to the imaginary part. So we'll be saying cos n theta is equal to cos alpha. From here, n theta should be equal to, the general solution of this is going to be alpha plus 2 pi k. That you should know from trigonometry. And if I want to get theta, then theta here is equal to alpha plus 2 pi k divided by n. So I can put them back there and get actually that my nth root of this would be r to the 1 on n cos sine of alpha plus 2 pi k divided by n plus I sine 2 pi, alpha plus 2 pi k on n. So that is actually the nth root of this. I would like that you keep this in mind when we try to solve this equation here. To get some space, I will do away with that, just so you don't ask questions when I then get the solution. So first, we try to express this in the form of polar coordinates or in trigonometric form. So to do that, we have to express it in the form r cos theta plus I sine theta. That's what we have to do, where r is the modulus of that complex number, 8 minus 8 root 3i, and that's just simply equal to the square root of 8 squared is 64 plus, if I square this, minus becomes plus, so this is 64, and the square root of 3, root 3 is just 3, so this will be 64 times 3 here. Can just make it nice. If I factorize 64 and look for that is 8. Factorize 64 out, I get 1 here plus 3 here is 4, and the square root is 2. So times 2, and that is 16. So my r is 16. Then theta is the argument of 8 minus 8 root 3i. And that is actually the arctan of the imaginary part divided by the real part. So that's minus 8 root 3 divided by 8. The 8 cancels and I get minus root 3. Tan inverse of minus root 3. We already indicated in one of our videos that this should be minus 60 degrees. So it means I can actually write my trigonometric form of that complex number would be 16 into bracket cosine of minus 60 degrees plus I sine of minus 60 degrees. So I can write this here. I can say z to the 4th power is equal to 16 into the cosine of minus 60 degrees plus I sine of minus 60 degrees. So this is what I have now, but I want the 4th root of that. I will write the general form of the root of that. So I will write it with k. So let's say each of the roots is, for example, w0, w1, w2, where the k represents each of the roots. So we should have 4 possible values of k because we need 4 of them. Then this is actually equal to 16 to the 1/4, a bit what we indicated there, because I'm taking the 4th root of both sides to get just one of these z's. But since there are many of them, I take a general form here. And we already saw that this angle will be modified. This will be the cosine of minus 60 degrees plus 36k degrees divided by 4 plus I sine minus 60 degrees plus 36k degrees divided by 4. 16 to the 4th power is 2 because this is 2 to the power 4. I can also simplify this here. 4 can divide this and I get 15. So that is cosine of minus 15 degrees plus 4 here is 90k degrees plus I sine the same thing, minus 15 degrees plus 90k degrees. So we are just left to simplify. So we would see what we get as a root of this for the different values of k. These k values, where my k go from 0, 1, 2, and 3, because I have only 4 roots. I should get only 4 of them. So when k is 0, I get the first one. When k is 1, I get the second. When k is 2, I get the third. And when k is 3, I get the 4th. So my wk is now in a nice form. This is 2 cosine of minus 15 degrees plus 90k degrees plus I sine minus 15 degrees plus 90k. So let me write the roots out. So W0 is when k is equal to 0. I put k 0 here. If I do that, I'm left with minus 15. So the first one is 2 cosine of minus 15 degrees plus I sine minus 15 degrees. So that's the first root. The second root, 1. This is W. W1 is equal to when k is 1. If I put k1 there, then I get 90 minus 15, and that's 75. So I get 2 here, cosine of 75 degrees plus I sine 75 degrees. 2. When k is 2, this is 180, and then I remove that there. So if I remove that, I get 165. Yeah, that should be fine. 180 minus that. Blah, blah, blah. 165. So this is 2 cosine of 165 degrees plus I sine 165 degrees. And the last root would be when that is 3. 3 times that is 270. And 270 minus that should be 55. 255. Then this is 2 cosine of 255 degrees plus I sine 255 degrees. So these are the 4 roots of this quadratic equation, where each of the root is a complex one there. I hope it was okay and that you were able to follow. If not, please leave me a note. We can make it better. Give us some thumbs up, and most especially, subscribe. Share with your friends. Those who don't have phones, please share with them. If you have a bigger screen, watch on a screen. If you have a computer, try that. Have a nice day. Bye.